Hello and welcome back to Yeyu Lab. Today I want to talk about document parsing, specifically how to extract clean content from complex documents like research papers, technical manuals, and financial reports. If you're working with document processing for typical LLM applications like RAG, model training, or just prompting creation, you probably hit those problems. Your extraction tool completely mess up the multi-column layouts of papers. Math formulas come out as scattered symbols, tables turn into unreadable text streams, code blocks lost all the formatting and indentation stuff. So today I will show you a small model called Dolphin V2, comes from ByteDance, which is an advanced, reliable, and open source solution that actually works on complex documents. Before we talk about the Dolphin details, let's see what people currently do for document parsing commonly. So most people still use the tools like PDF Plumber library for simple documents parsing because it's very fast and it's free. But you will see problem when you use it on a research paper. Here is my test code. I want to use it on extracting the content from this technical paper. It has 2 columns. It has some formulas and tables. So let's see what happens finally. If I run my test code, the PDF Plums can generate basically what's included in its PDF file. But you can see the problem, right? Sometimes it can recognize the column, but sometimes it cannot. Like here, it messes up 2 columns into 1 line. The column boundaries get completely ignored here, and the sentences are broken in random place, including the boundaries of the words. And also in this output, the math formulas are unreadable. These are basically unusable factors for any serious application by using the libraries like PDF Plumbers. The other solutions is that you can use commercial APIs like the Gemini model. This is also a test code that I simply use Gemini to parsing documents as a image understanding task. And actually it can give much better results because it is a commercial high-end models. Its capability is very powerful, but they cost real money. Processing 100 documents costs around a couple of dollars. That adds up fast. Another issue is the document privacy. If you are going to parse some documents that is highly secured, using commercial API will be a potential issue. So what's the difference about Dolphin V2 to this solution? First, it's built specifically for documents understanding. The ByteDance releases in December 2025, and it's a 3 billion parameter model that can run smoothly locally. The key innovation is its 2-stage processing. The stage 1 figure out what kind of documents you have from the digital PDF to photographed page. Stage 2 picks the right parsing strategy based on that analysis. So by this way, it can process all different type of the documents on your hand. So from the element perspective, recognized 21 different document elements, which including text, paragraphs, math formulas, code blocks, tables, headers, footnotes. Each element gets specialized processing separately. And then here is what's really good about it, because it's only 3 billion size. So we can run it on the free version of Google Colab with 8-bit quantization. It only needs 5 gigabytes of GPU memory from a test. That means you can use it right now without buying any expensive hardware or pay for any API cost. Because it is designed specifically for document parsing, so performance on this area have very solid numbers. You can see the Dolphin V2 has 89.78% overall accuracy for document parsing. The math formula recognition is 87%. Table structure preservation at 90%. These are real-world usable results that we can actually use it in our commercial projects. So by understanding that, let's see it in action. Now let me show you how to actually use it. I'll walk you through the Collab notebook of its setup and running step by step. So first, we should clone the repository from GitHub and install all the required libraries and the bitsen bytes and accelerate for later quantization process. And then we should download the model Dolphin v2 from Hugging Face. This will download about 6 gigabytes of model files and take a few minutes on Collab. After that, you will have 2 main working folder. One is the Dolphin, which includes all the application demos, and the other is the Hugging Face model folder, which includes the model files. Now we can start testing different document types from next command. Here you should note that the official demo scripts are not containing the quantization support. So I have to add these by myself. If you look at my code here, this is also the clone of this Dolphin demo code base. There are 3 main demo scripts: demo elements, demo layout, and demo page. For each one, I add the quantization part here by changing the original pre-trained function into the standard auto processor from pre-trained model from Hugging Face, and add the options of quantization for 8-bit and 4-bit, integrate into the command. So please do not forget to replace the original code with my code here in the file system of your Collab notebook. These 3 files. Okay. Now for the first command, we use the demo page script to process page 1 image with quantization of 8-bit. The demo page is the entire processing with the Dolphin model. This will process an entire page with the code examples. The output preserves all the programming syntax, indentation, commands, and everything stays intact. What I mean is, when you go into the demo folder, the page images, you can open the page 0 JPEG. This is a page including headers, paragraph text, and code blocks. When I run this command for page 0, there will be 3 new folders created after completion of this script. The output JSON, let's see page 1 JSON. The output JSON will include all the blocks inside this document with the label to indicate what type of the block is, like paragraph, section 1, code blocks, and footnotes, and captions, which is clearly list the type of each blocks. And in the B box area, it gives the exact positions and the size of the blocks with 4-dimension data. So to prove that, it also provides markdown folder, which including the markdown file that precisely clone document into a markdown file. You will see this markdown file is exactly the same with the original document in JPEG, right? With the headers, paragraph, and code blocks. There is also another interesting features that it can provide: the layout visualization, which is the validation of what provided by the JSON with the content and the B box and the labels. Let's see page 1 layout PNG. It is basically a copy of the original image document, but it labeled all the different blocks with different colors that exactly bounds the blocks. And you can also see these small labels that list for each block. This is very useful when you provide visualized application for document extraction. So by the same method, I also run the script for page 1 and page 2. Let's see the original image of page 1 and page 2. Page 1 is an image document that, including math formula, injects the text paragraph. When opening the page 1 JSON file, you will see the detail of each blocks, including headers, half paragraph, and paragraphs. The interesting part is the equation label, which include the text with the entire equation that lists in the documents to proper LaTeX notation. To verify that, you also can go into the layout visualization of page 1 to see the visualized boxing bounding for each blocks with correct labels. And for the page 2 processing, when we open the page 2 JPEG original file, this is a copy image from the technical paper, which is a very common structure that has 2 columns with citations, reference, headers, abstracts, which are the typical formatting elements. Let's open the result to see whether the Dolphin V2 can do it well. We open the page 2 JSON. Yeah, you will see the label abstract, paragraph, and each paragraph looks very individually complete without mess up with other paragraph in different columns. If you open the markdown file, you will see the image-based documents has been well captured with right paragraph settings. There's no 2-column mess up inside this markdown clone. And even you can see there is a label here which is labeled as watermark in the original paper that lists vertically aside of this page. Okay, these are the entire demo page script. If you only want to have the layout, you can run demo layout script to save your time and GPU usage without getting the content of each blocks, but only cycled the layout. I run this layout script for page 8. So let's see the original page 8. Yeah, page 8 is another more complex paper image type listed in multiple mathematical equations. So you will see the output of JSON structure for page 8. It will just give you the position and dimension of each block with only labels. So it will not extract the text for saving times, but give you labels that you can use the label and bbox data to do the visualization for your application like this. Okay, and the last one, I'm testing page 6, which is a PDF file with multiple pages, and I run it with demo elements script, which is used for the certain elements from the documents by indicating the type you want to get. Here I set the element type as table. That means I want only extract the table from the entire PDF files. It will take time because I have multiple pages. For the certain output right now, you can see for the JSON file, it's only about the table with the label and text, without any other type of blocks. For page 2, another table, and the table content also listed. So this is quite helpful if you want to save time. So the Dolphin V2 gives you a practical solution that balances the quality, costs, and operational requirements. I think it's advanced enough to handle complex documents, reliable enough for production use, and free enough to deploy it without budget concerns. If you want to try it yourself, all the code, including the updated demo code and the Collab notebook, are all available on my GitHub repository. That's all for today. If you have further questions or ideas, please drop them in the comments below. Thanks for watching. I'll see you in the next video.